We're studying ICT, chapter 1, 2, part 2. Let's say part 2, 109. Let's say part 3, I think. Now, today we're learning all about what things we're learning about types of software.
Okay.
We're learning about types of computers. We're learning about types of interfaces. 3 things. That's today's agenda, perhaps. You can say that.
Okay.
Now, let's start here. The first thing first. Types of system software. Types of software. Now, software are of 2 types. Software is of 2 types. How many types? Write it in your notebook. Get your notebook ready. Software. Ranjana, ready? Writing?
So first what I have to write?
This.
Okay.
ICT chapter 1, part 3. We have these things happening. Types of software, types of interfaces, types of
So what's
computers.
the meaning of agenda?
What is the meaning of?
Agenda.
Agenda means goal. Write that in your notebook as well. Use that in English. Write the word agenda and write the meaning goal. Because I'm not teaching you to forget, right? So whatever you learn, try as best as you can to remember. Now, done writing this part. You don't have to write this. Only write this part only. Now, we're starting with software. Yeah, and the first thing is system software. We look at that. What kinds of system software do we have? We have a lot of things, especially about this. Right here. So we have compiler. We have linkers. We have device driver.
Charu.
Finally, we have operating system. Write this in your notebook, no screenshots, nothing. Just write it, tell me when you're done. Done. Now with system software, I'll just give you a definition of what it is.
So I have to write that also.
Yes. That is the main part here.
Okay. So the compiler, linkers, device, driver, everything is example.
Example, yes. Now you need to know what these are the examples, because in the exam they'll ask you to match.
The example, it is EG or EX.
You can write both, EX, EG, your choice. EG is the proper word. Doesn't matter, write this down best, ICT. Done? I'm going to give you a question. Niranjana, read the question.
Explain what is meant by system software. So these are past paper questions.
Yes.
So like this, the questions will come. So we have to answer them.
Yes, you have to answer them. There's no MCQ in ICT.
So it's mostly question answers.
Yes. Now, okay, wait. So I'm so sorry. Is this what you wrote? Now, please remove this and write. Okay. Don't remove it. Don't remove it. Instead of this, just write. It's in terms of system software. You can cut this part out and say application software. And but these guys are for system software.
Okay.
Just a second.
So application software, right?
Yes, application software.
So what's for the other one?
This is before the other one.
Oh. Software.
2 marks.
So mostly how much hour the paper is for?
The paper is exactly for, they're different, but usually 2 hours. Theory is for 2 hours. Practical is for 2 hours and 30 minutes. So you have enough time. Well, you don't have enough time. There's a lot of questions. You have about 15 questions in the exam, and each of them have about 5 parts.
15 questions.
Yes.
So it's very long or?
Very long. Now, have you written this?
One exam writer.
Examples are compiler, linker, device driver, utilities, and operating system. Those are the examples of.
So the compiler is interface between the computer hardware and the user application.
Not the compiler, system software.
It's the second part.
Yes, of system software.
Okay.
Because the question will be for 2 marks in the exam, maximum.
So as much as information we have to write down.
Yes, the more explanation, the better. But unless they're asking you for only a few explanations, it will depend on the question. I'll tell you what kind of questions you have. Okay, don't worry.
So it's like we have to learn everything by heart to answer the questions.
Yes, learn everything, memorize everything by heart. And if you can do that, then you're getting full marks in ICT. It's more about so practical is not for memorizing, but theory, if you memorize the whole book, the notes which I give you don't have to memorize the book. But if you memorize the notes, you're getting A* easy. Okay, but only if you solve past papers and join classes on time. Otherwise.
So for this also there is past papers?
Yes, Niranjana, there are past papers for all of them. We have to finish the syllabus and we'll have to practice the past papers. Okay, now have you written this? I'm going to move on now.
Yep, done.
Now you should write the examples of application software. These guys. Write word processing, write spreadsheet, write database, remove this thing. We need to write that, remove this, and write apps. Or instead of that, so don't write apps actually, write these. Stop. Write these.
Video editing graph.
Yep.
So I have a question.
Ask me.
So they use this application software for like the graphic designers, they use this application.
Yes, they use this. Graphic fashion design and everyone uses this.
So can I scroll up because I didn't finish writing the examples.
Finish. Done.
Oh, 1 minute. Sir. So spreadsheet is one word or two words?
One word.
Okay.
Now let's continue. You can get these in the notes, okay? Continue. Come here. Explain what is meant by system software.
So only the graphic, this thing is left. 1 minute.
Graphics editing.
Oh, the spelling wrong. I see. Done.
Now look at the question. Read the question, the first one.
Okay. Explain what is meant by system software.
Read the answer.
So which I wrote in the notebook?
You don't have to write it. You have already written it. Just read the answer on the board.
Okay. Programs that control and manage the computer's hardware, and it runs the application software, interferes between the computer hardware and user applications.
Interface. Isn't that what you wrote? Check your answer, compare.
For application software?
For, yeah, now tell me the answer for application software. From your notebook.
Application software, I wrote programs that allow the user to do specific tasks.
Now read the answer.
Yeah, it's the same.
Same example for choose two types of system software. Choose. Which are they?
You have to circle them.
Yeah.
It is system software. So it will be Linux, and then where is the other one? Operating system.
I think you have written it here. Yeah. Linkage operating system.
Yeah, we wrote in example.
Fine. We're going to move on in the book. Now that's all you need to know. Analog and digital data. Now one thing, Niranjana, can you see this right here? This page,
Yeah.
Page 5. Now these are also important, but you will have to read them on your own. I'll give you the notes, okay, to find out the definitions of all of these. So these definitions are important. Okay, but it's just memorizing from the notes for this. I'm going to move on from this now. We'll come back to this when we're solving questions.
So only this memorizing part is there, and for practical, what will you do?
Practical, we'll be doing it on the computer. Yeah. Now that's
Yeah.
So we'll open with Rania. I did a practical when you were absent. We did
So
practical.
Practical. I never did
Yeah.
it.
If you want to do a practical, then you have to join the classes on time, and yeah, then we can do it if you have extra time. So when we finish this chapter, we'll start a practical chapter. Okay.
Okay.
Now compilers, linkage, right? We know all of this. Let's move on. Analog and digital data. Read it from here. Read only the highlighted part.
Yeah, so
Read only the highlighted part, which on the board.
computers only understand data in a binary format. So what's that?
Read after that value 0 and 1.
Value 0 and 1. This
Binary
is
means, what is the meaning of binary?
data.
0 and 1. How many are there? How many digits are these?
0 and 2.
2 digits, right? So 2 digits, 2 means binary. The word 2, that's where the bi comes in. Binary. So 2 digits, so we call it binary. Is that clear? So it's always 0 and 1. Is that clear? Ones and zeros. Write it in your notebook. What is binary? Ones and zeros.
Yeah.
Now I'll tell you what to write. You don't have to worry right now. Just read. Don't write right now. Okay? Don't write this. Continue reading. Okay, start from the beginning again.
Computers only understand data in a binary format, value 0 and 1. This is to digital data. Data in the real is the analog. Analog data is physical data that changes smoothly from one value to the next.
One value from the next. Okay.
So
Now,
it's graph.
if you look at the graph, look at the graph here. Now, digital data is, let's say, it can either be one. That's okay. Now you tell me. In let's say in basketball, yeah, what scores can you get for one shoot? If you shoot in the hoop, what are the possible scores?
First one you get 1, and if we shoot from far away, we get 3 points.
Yeah, so if you shoot from inside the circle, the 3-point line, you get 2 points. If you shoot above the beyond the 3-point line, you get a 3, right? So you can get points in basketball are either 2 or 3. Yeah. So there are only 2 possibilities. That's called discrete because we only have these fixed values. On the other hand, what heights can people have? Heights of players.
Person to person.
It changes, right? Some person can be 1.65 meters, or some can be 1.81 meters. Some can also be 1.8 to 1.125 meters, right? You cannot measure it. You cannot measure it exactly, can you? It's very smooth.
Can by using a machine.
You can measure it, right? But can you measure it to exactly? Let's say, can you measure it to 500 decimal places? No, right?
No.
Because always there will be some changes. If someone is 1.65 meters, they can be 1.651 meters as well. Yeah.
Yeah.
So we don't know how exactly they are. Then we can only measure it to a certain degree.
Mostly 1 or 2 decimal places.
Decimal places. But on the other hand, points in basketball, can you score 2.15 points or 2.151 points?
It's a whole value.
Oh, it's only 2. There's no other possibilities. Yeah. So that is the difference between analog and digital. Is that clear? Digital can only have fixed values. Analog can be anything. Okay. Analog is real life. Let's say, let's take another example. Perhaps let's say we can take let's say how loud something is. Okay. And we can compare this with, let's say, we can compare digital data with binary. Okay, that's discrete. Now, just like points in basketball, binary data is also discrete. It only has 0 and what?
1.
1. Now, loudness. If we can also measure loudness, so we can say 100 decibels. That's decibels is used to measure loudness. Now, this is in, let's say, home. Okay, that's the loudness in home. But if I go to a concert, will it be more loud in a concert?
Yeah, it will be loud.
But can I measure it exactly? It can be 1.59006 decibels. Yes. It won't just be 100,000. It could be anything. If someone else starts shouting, the decibel will increase. If everyone goes silent, it will decrease. So it's not fixed. Is that clear?
So the analog is not fixed.
Yes, but digital only has, what does it have? Discrete values, or it only has fixed values. Is that clear? What does it have?
So
Fixed values.
the digital data has fixed value and analog doesn't have.
Yes, I'll just write it on. No, write this in your notebook. Digital data, binary, and has fixed values of 0, or let's say 1 or 0. Is that clear? Now for analog, we have this is continuous.
So it's digital binary data or
Digital is binary data. It doesn't make a difference, right? Just need to know is that digital is binary. On the other hand, let's say, okay, let's take this guy. Digital data is binary. Continuous data, analog is data is continuous. Okay, so we can write here, not fixed values. Right? That's it.
analog.
Write this as well.
Okay. So what is this?
Discrete. Discrete means fixed. So it's just a fancy way of saying fixed values. Okay. Now tell me when you're done writing. This is not the most important aspect of the chapter. We have to move on. All right, we're going to move on. You can.
Done, sir.
Done. Okay. Now right here, I want you to write this down as well. Write this, and write this. Okay. Now, easy analog to digital converter converts analog data to digital data. So just write it down in your notebook. You don't need the definition right now. Just write this there, which is used to convert analog to digital. I think that makes sense, right?
So what to write?
You have to write these guys. Let's say converting. Just write
Analog to digital data.
converter. 1 and 2. In converting, write 1 and 2. This is 1, this is 2.
Okay.
Give the heading converting data.
1 minute. Okay, so these are the examples 1 and 2, right?
Yes, analog and digital converter, digital to analog converter, DAC.
Okay. So in class we did a presentation also.
We did a presentation also. That's good, but you need to realize that the book, all you have to do is memorize the book and solve past paper questions. Okay, because I want you to get the most marks. You don't have to do a presentation on this. All you have to do is solve the past paper questions, which I'll give you in the GCR, right? And
if it was, I guess she take it for assessment, the project.
That's good. That's good for you. But you should, we're preparing for the final exams, right? Now I have to, my job is to make guarantee that you're getting an A star, right? So just finish writing, and let's continue. Okay.
Yeah, done.
Done. Okay. My main components of computer systems. What are we doing now? Read it. Main components of. Start. Come on. We don't have time.
Yeah.
Niranjana, can you hear me?
Main components of
Yeah.
computer systems.
Systems. Now, the main things we have are these guys. We have input devices, output devices, and secondary storage devices. What do we have?
Input devices, output devices, secondary storage devices.
Secondary storage devices. Now, what else do we have here? We have some internal hardware. We have done this already, yes? CPU,
Yeah,
RAM,
CPU,
ROM.
RAM, and ROM.
We have done
did
that.
it. Yeah,
We
yeah.
did motherboard. But the thing is, there's another one, which is internal hard disk called solid state drive. This is internal, and you also have external. So they're
So
also,
you
yeah.
told me about this SSD.
Yes, I told you. So what we need to realize is that these guys are also can be both inside and outside.
Really? So, ROM contains ROM contains boot file. The code tells the computer that to do when the first start up. BIOS, basic
BIOS.
input or output system.
BIOS. You said BIOS. What is it? BIOS.
BIOS loads the programming system into the RAM. BIOS stores the data, time, and system configuration in a non-volatile chip called COM.
CMOS. Called CMOS. Okay.
Compulsory metal oxide semiconductor.
No need to know this. Non-volatile chip called CMOS. Now, I have been working with computers since I was 3 years old. So I've seen all of this. I can show it to you as well after someday. Now, let's start reading here. Niranjana, read this.
RAM, temporary memory device, volatile memory can be written to read and to write form, used to store data, files, programs, part of operating system OS currently in use, can be increased in size to improve operational speed of a computer. ROM, permanent memory device, non-volatile memory device, read-only data stored cannot be altered, used to store files and other data needed at startup.
Yeah, you need to remember this table. It's for 5 marks.
So 1 minute, can you show the table once again?
Now I'm going to upload this book. You have to download it after class.
Okay.
Now, okay, next thing is input versus output devices. Again, this is important. 5 marks. Input versus output devices.
Okay.
Done. Can I move on? Now you have to
So this
read
one
this.
also I have to learn.
You have to, yes, you have to memorize this. I'll give you better notes, but you have to memorize these. Understand at least.
Okay. Input devices and input
You don't have
device
to
is
read,
a
not right now.
hardware device.
You don't have to read because we have done this, yes? What are input devices? They take in data, yeah? Output devices give you some data.
Yeah.
Yeah, okay. When you read this, you'll realize that it's not that difficult to read this part. And if you have any doubts, ask me. Right? Input and output
Okay.
devices. Now, backing storage. Read from the beginning.
Backing storage, the main. So you will highlight or I have to read more?
Read it. Read the whole thing.
Okay. The main memories in a computer are RAM and ROM. However, to permanently store large amounts of data, it is necessary to use backing storage. This normally takes the form of internal hard disk drive, HDD, or a solid state drive, SSD. This is
Internal.
the
What is
computer's
it? Read the word
internal.
here. Internal. So we're not talking about outside people here. We're talking about internal things only. Okay,
Yeah,
internal hard disk. Okay, continue. Because these can also be external, by the way. Yeah, you have seen those external pen drive, hard disk, which you can connect to your computer. Those are external. Now,
yeah.
backing storage is internal. Internal. Why do we need this? Because you have to store some data in your computer. Okay.
Okay.
For example, you want to store a photograph. Where will you store it?
So storage in the
Folder, a
gallery.
file, gallery, right? Have you ever gone to C drive or D drive? Those places in the computer?
Just like this.
Yes, you have. Right now, if you look at computers, they have different devices. They have different hard disks. Right? Look at this. Can you see this on the over here?
Yeah.
C drive, D drive, E drive. Now, all of these have some storage capacity to it, where we store some files. That is what we mean by backing storage. Is that clear?
Yeah.
Read the highlighted part again.
Backing storage to permanently store large amounts of data. Use backing storage, the internal hard disk drive HDD or solid state drive SSD.
Stop.
Application software, disk operating system, and files are stored.
Start again. Where the application software?
Where the application software, disk operating system, and files are stored.
Right. So application software, operating system, and files are stored. Now, one thing you need to realize is that these must be non-volatile. What is the meaning of volatile? What is the meaning of volatile? Can you hear me?
Yeah, sir.
What is the meaning of volatile? We have done this already in class.
Volatile means when the data or the information will be lost when we off the power unit.
Yes. So if you store a photograph on a computer, do you want it to be lost when you close the computer?
No.
No. So they must be non-volatile. Right. Unlike RAM and ROM, they are volatile. Now, one thing you need to realize, they are also not directly addressable, which means cannot be read directly by CPU. Just forget this guy. Read the highlighted part.
Okay.
Read this part first.
So so is it why when some hackers access to our account, our messages and everything starts to disappear because they're doing something like this, like volatile things?
No, they don't. This has nothing to do with volatile. Volatile is hardware. Okay. RAM close. See, when you place something on the RAM, the power goes off, the data goes away. It's temporary. It's not something to be permanent. On the other hand, your hardware has to be permanent. It should not go away. It's something to store somewhere, right? In the same way, let's say, do you have, let's say, a water bottle?
Nearby?
Do you have a water? No, not nearby. Or any water? You have seen one? Yeah, in your real life. Yes, in real life, you have seen a water bottle. Perhaps it has a cap on it. Yes, this is what it
I
looks
don't
like.
use water bottles.
You must have gotten one, perhaps, Safa or any water bottle. Now that's a water bottle right here. It has water in it. Yes.
Okay.
If you flip the water, should it fall out? If you flip the bottle, does the water fall out?
No.
No. Now you have a glass. It also has a water. Also has water in it. If you flip the glass, does the water fall out?
Yes.
So glass is temporary, while the bottle is permanent water storage. So this guy stores, it's for storage. Okay. Imagine this as backing storage. While this guy is temporary. Is that clear? Make sense? So this will not go away if you lose the power, but this guy is temporary, it goes away, it's volatile.
Yeah.
Is that clear? Fine, let's move on. Now, now you don't have to care about, forget the internal part actually. Let's continue over here. Read from here. From here. Or read from here. The whole thing. Yes. Start. Continue.
That storage can be either fixed very often, internal to the computer, or removable.
Right, it can be fixed or internal. Another thing is can be used as a backup in case of data loss or
is
corruption.
that it can be used as a backup in case of data loss or
Data can be copied.
Data can be copied into another device.
Right. Now, examples of removable storage are external hard disk, these guys.
External hardwares, HDD, external solid state drive, SSD, or Blu-ray discs.
Blu-ray discs. Have you seen those CD discs? CD?
Yep.
Yeah, those are them. But you can remove them, yes. They have movie on it.
Yeah.
That's it. So movie is the file, they are the storage, they're removable, you can remove. So they are removable storage device.
Okay.
Now you have to just read this table. It has everything here. This, forget this, all this is good. You can read this once, read all of this once, and then memorize the table only. Is that clear? This is again for 6 marks, not 5 marks, 6 marks. This is more important. Any doubts?
No,
so
sir.
far? Now in the next class we'll be doing operating system and different types of computers. Okay. Fine. Now one thing. Just a second. So this class is over. We're done for today. What did we do to study today, Niranjana? Tell me.
Today we studied about software. There are two types of them, applications and then system software, and we learned the definition of both of them and examples of both of them. And then we learned about non-volatile, volatile, and then we did about analog and digital data. And yeah, that's it. And the meaning of binary.
Binary, yeah. And we also looked at what difference between RAM, ROM. Now please write in your notebook. Write this in your notebook. Write RAM versus ROM in your notebook. Just write as a heading and give page number 8. So I need you to write this in your notebook. Make a bullet point perhaps and say RAM versus ROM. And you'll write 5 marks here. And you'll give page number 8. Tell me when you're done writing. Done?
Yep.
The next thing is comparison of input and output devices. Just write input device versus output device. Input versus output device. Output devices. Page number 9. Done?
Not yet. Yeah.
Last thing, which is backing storage versus internal memory. Versus internal memory. Page number 10.
Done.
Done. All right. Now that's enough for ICT today. Okay. Now stay here for a second.